I think screen is not shared. Okay. Can you hear me?
Yes,
Guys,
sir.
can you hear me? Getting my point? Why to use MOSFET in the common source? The first advantage, there are three types of MOSFET amplifications or AC amplifications. MOSFET can be used as an amplifier. There are three types of using the MOSFET as an amplifier. The first one is common gate, where input is connected to source and gate and output is connected to drain and gate. Then second one is common source. The input and output is as shown in the circuit. Input is connected with gate and source and output is taken between drain and source. This is also called common source MOSFET. Here in the circuit you will find it is mentioned, it is common source MOSFET. Okay, this circuit is very common among all and it is essential to understand this circuit, otherwise in every circuit henceforth we will refer common source MOSFETs. Whereas third configuration is common drain. In a common drain there is drain point which is common. Input is between drain and gate and output is between source and gate. So that is also called common drain configuration. Common source configuration is better than rest of the two. Why? Because as far as voltage gain is concerned, common gate is having very high gain, common drain is having low gain and common source is having medium gain. But input impedance of common source is medium, input impedance is medium, voltage gain is medium, current gain is medium, power gain is very high, output impedance is also medium. Everything is optimized in common source amplifiers and that's why it is preferred. Even phase shift between input and output is 180 degree. In a figure you will find that it is 180 degree out of phase. Input is having very weak signal like millivolts. It is given here, input is given as, input voltage is given as very low signal in millivolts, whereas output signals are, output voltages are VDS which is very high. Output is in volts whereas input is in millivolts. The phase shift between VGS, this is VGS and this is VDS. Phase shift between VGS, VGS is considered as input signal for common source whose input is in millivolts and whose output is in volts. Now you will find that input is this way, output is this way. That means there are 180 degree phase shift between input and output in the common source. Whereas in a common gate and common drain there are 0 degree phase shift, means input and output are in phase. Till then we prefer common source because it has medium input impedance, medium output impedance, high power gain. That's why it is preferred. Now what about common gate? Common gate, it is having high voltage gain, it is having low current gain, it is having low power gain and it is having low input impedance and high output impedance. Why we don't prefer common gate though there it is having high voltage gain? because input impedance of the common gate amplifier is low and output impedance is high, which is not expected in any circuit. Where in common drain voltage gain is low but current gain is very high. Though current gain is very high, input impedance is high and output impedance is low in common drain, but voltage gain is low. That's why we will not consider that thing also. So common gate and common drain we will not consider, though there is having high voltage gain, but input impedance is low and output impedance is very high. That's why we will not consider. This is difference between common gate, common drain and common source. There will be a question of 8 marks. Differentiate between common drain, common gate and common source voltage amplifiers using FET. Which type of difference you will write? In common source, everything is in medium range. That is, voltage gain is also medium, current gain is also medium, and power gain is also medium. Input impedance is medium, output impedance is also medium in common source amplifiers. In common drain and common gate amplifiers, it is not the case. Voltage gain in common gate is very high, whereas in common drain it is very low. Input impedance is very high in common gate, and in common drain input impedance is low. Output impedance is is high in common gate, and in common drain it is low. Means common gate is not preferred because input impedance is low and output impedance is high, whereas common drain is not preferred because its voltage gain is less. This is difference between common gate, common drain and common source amplifiers. What about phase shift of common gate and common drain? It is 0, whereas in common source phase shift is 180 degree. This is difference between these two. Now let us understand how signal is amplified in the common source. Common source is equivalent to common emitter amplifier in the transistor amplifiers. Transistors can be used as amplifier, even Mosfets can be used as amplifier. Mosfet is having very high input impedance, low output impedance. Even gain of the Mosfet is low, but transconductance and power generation will be less. Mosfet will be cooler than BJTs. That's why we use Mosfet as amplifier than transistor as amplifier. The second advantage that Mosfet can be used instead of transistor is what? Power required is less in Mosfet, whereas power required or voltage required in transistor is more. The third advantage is that Mosfet required very low space as compared to transistor. And fourth advantage is that Mosfets are unipolar, whereas transistors are bipolar. And so the heat generated in Mosfet is less as compared to heat generated in transistors, and hence Mosfet can be used as an amplifier. Now let us understand the circuit analysis of Mosfet, common source Mosfet. Circuit analysis or AC amplifier. Transistor Mosfets can be used as a common source amplifier or voltage amplifier. A voltage is amplified. The main advantage why to learn any device, it is important to learn any device. Why? Because it can be used as an amplifier, signal amplifier, it can be used as a attenuator, it can be used as a voltage, it can be used as a frequency filters, it can be used as a low pass filter, it can be used as a high pass filter, it can be used as an adder, it can be used as a multiplier, it can be used as a divider, and so any type of operation can be performed using Mosfet, and that's why Mosfet is used. Any type of operation. Say, what are the operations that can be used on any analog signal? Multiplication, division, then low pass filtering, high pass filtering, then there will be attenuation, there will be amplification, everything can be performed on any signal, and hence MOSFET can be used in analog circuits. Let us understand common source amplifier circuit. Rest of the circuits we will just learn incoming signals, incoming chapters. See, Vs is a AC signal that we are applying. Our signal is signal in series with V in a graph. You will find it in a graph. This is Vs. Vs signal is this. This 0° sine wave signal. Okay. Signal is, this is AC signal whose input is fed to R signal and then to the gate. It is connected to, as gate is P type material. During this positive half cycle, let us understand what happens to positive half cycle. During positive half cycle, this connects to gate. Gate is P type of material. This becomes forward biased. Gate to source connection, gate to source becomes forward bias. As this gate to source become forward biased, and also drain is connected to plus VCC, and drain is N channel, N plus material is there, N channel is drain, and P type of material is gate, and again N plus material is source. So this is reverse biased, and this terminal, this is forward biased, and this is reverse biased because it is N, P, N type of material. So during this positive peak, this becomes forward biased, this becomes reverse bias, and this current starts flowing. As this is transistor, during positive peak there will be a voltage current flowing in this direction. Current flows through this in this direction. As current flows in this direction, voltage VDD, V load voltage, VL or output voltage is measured across load resistance. So this output V0 is equal to VDS minus ID into RD. So output V0 is equal to VDS minus ID into RD, and which is nothing but negative, inverse. Output is, see, in a transistor also, transistor equivalent circuit I am drawing. Transistor equivalent circuit is, this is equivalent VCC, output V0, and this is emitter. During input positive, output I am getting V0 as negative. In transistor as a common emitter amplifier. The same thing is there. It is as good as we are connecting, this is RC and this is V0, RL, this is RD, we will say, this is VCC. So output V0 is given as V0 is equal to VDD, VCC minus IC into RC in common emitter configuration. Now in BJT it is output is reverse. Here V0 is given by VDD minus ID into RD. So output is VDD, V0 is negative. If input is positive, output V0 is measured across this point. This point voltage is this voltage minus this voltage. So this point is negative. So output is negative. During positive peak, output is negative. During positive peak, output is negative. Okay. During positive peak, output is negative. And during negative peak, output is positive. During negative peak, output is positive. So it is 180 degree out of phase. As I told you, it is 180 degree out of phase. As shown in the figure, if input becomes positive, this becomes forward biased, circuit becomes forward biased, and current flows through this. As current flows through this, voltage drop across this reduces, voltage drop across VDS reduces, and V0 is negative during positive peak. During positive peak, V0 becomes negative, and during negative peak, output becomes positive. Why? Because current increases. Current flowing through this ID increases. As current increases, ID increases, drop across this decreases. That means ID current flows increases, drop decreases, drop across this drain to source decreases, and hence as a voltage it is reducing. As a voltage it is reducing. Means during positive peak voltage reduces, and during negative peak voltage increases. This is what we learn from this common source amplifiers. Now what we have studied today? We have studied AC analysis of common source, working principle of common source. If there will be a question of 8 marks in the examination, draw and explain common source amplifier, you have to draw this circuit and you have to draw this graph. Both you have to draw this circuit and graph. If equation arises like this, draw and explain common source amplifiers, then you have to draw both. And how will you explain? During positive peak, drain to source current increases and drain to source voltage reduces. Output is nothing but drain to source voltage, and voltage drop across this which is reduces. The NPN type of material is there, and junction is PN junction forward biased, and this NP junction drain to source NP junction is reverse biased. Like this you have to explain. So this total carries 8 marks to you. Now we also have studied difference between common gate, common drain and common source. What is difference between common gate, common source and common drain? In a common, let us understand difference. Voltage gain, in a common gain it is high. I will write over here difference, because difference also it is of 8 marks. Difference is 8 marks. Gate, drain and source. common gate, common drain, common source. Voltage gain is high, it is low. Voltage gain is low, it is medium. Current gain is low, it is high, it is medium. Then power gain is low, then it is medium and it is high. Then Z0 output impedance, it is high, it is low and it is medium. Then phase shift 0, 0 and 180 degree phase shift is there. This is the difference between common gate, common drain and common source. And as far as gain is concerned, it is medium at all places. Even phase shift is 180 degree and output impedance is medium. Input impedance is also medium, output impedance is also medium. R0 is output impedance, which is medium. So this is difference between common gate, common drain and common source. This carries 8 marks to you in the examination. So keep in mind that common source is very, very common among all. Now let us understand frequency response for amplifier. Amplifier frequency response in a common BJT frequency response, BJT common emitter amplifier frequency response is like this. And FET frequency response is same. This is low frequency, this is medium frequency and this is high frequency response. Frequency response of common source amplifier is, this is common source amplifier. Frequency response of FET is same as BJT. Which are the frequencies? How we have analyzed lower frequency up to 30 Hz to 300 kHz, it is considered as medium frequencies or low frequencies. 300 kHz, less than 300 kHz low frequency, less than 3 MHz is medium frequency, and less than 300 GHz, 300 MHz is high frequency. So high frequency is 3 MHz to 3 MHz to 30 MHz is high frequency. So this is low frequency. During low frequency, gain of the amplifier frequency response is low, gain is low, and at medium frequency gain is high, and at higher frequencies gain is also low. So this is what the gain of frequency response for amplifier. Why it is so? Now the question is why. At lower frequencies, coupling capacitor works as an open circuit because Xc is equal to 1 upon 2 pi Fc, and so coupling capacitor acts as an open circuit, and coupling capacitor does not allow low frequency Vs to transfer to FET. During medium frequency, voltage is transferred to FET. So gain of the amplifier during medium frequency is very high, and at high frequency transconductance capacitor present in the FET does not allow higher gain. So During low frequency and high frequency, gain of the amplifier reduces, just like in the FET, just like in a BJT also. BJT common emitter amplifier, the same situation occurs. That means during low frequency, coupling capacitor works as an open circuit, and during high frequencies, transconductance capacitors present in the inside a FET or capacitor present in the FET or BJT acts as an open circuit, and so gain of the amplifier reduces. This is gain of the amplifier. This is gain of the amplifier. This is gain of voltage gain versus frequency. Voltage gain versus frequency amplifier. During low medium frequency, gain is very high. This is low, medium and high frequencies. Low, medium and high frequency. During high frequency, FET is working as a attenuator, or let's say it is having very less gain for during high frequency. During low frequency, gain is also low. Why? Due to coupling capacitor. This is due to coupling capacitor present in the this is high frequency, this is medium frequency and this is low frequency. During low frequency, coupling capacitor is present over here. Coupling capacitor remains present over here, and hence coupling capacitor is also present over here. This capacitor acts as an open circuit during low frequency. During high frequency, capacitor present in this FET is acting as an open circuit, and hence gain reduces during high frequency. During low frequency, this capacitor is reducing gain of this amplifier, and gain remains very high during this medium frequency only. So this is what a frequency response for amplifier is. Which is low frequency? 30 kilohertz to 300 kilohertz is a low frequency, and 300 kilohertz to 3 megahertz is a medium frequency, and 3 megahertz to 30 megahertz is a high frequency range. There are also very high frequency range, that is 30 megahertz to 300 gigahertz. It is a very high frequency range present in the, and which is used for TV or TV circuits. Mobile communication is working in a very high frequency range. So this is what a frequency response for amplifier is. This completes your unit number 1. All of you, this completes your unit number 1. Getting it? This completes your all participants. This completes your unit number 1. Understand? Guys, this completes your unit number 1. Do you understand?
Yes.
Apeksha, Rutuja, Shubham and all? Okay.
Yes, sir.
Frequency response for amplifier is also there. This completes your unit number 1. We will switch to next unit in the next lecture. As far as this unit is concerned, first unit is concerned, what we have studied? We have studied characteristics of FETs. Then we have studied frequency response of common source amplifier. Even we have studied common source amplifier. Everything is just like a bipolar junction transistors. Even working construction and symbols of FETs we have studied. This part there will be always a questions like draw symbol of FET, MOSFETs. Then what are the characteristics of FETs? That is R0, Ri, that is input impedance, output impedance, transconductance, then effect of temperature, body effect. These are the characteristics. Common source amplifiers, there will be draw and explain common source amplifier, may be a question. This carries 8 marks. Frequency response for the amplifier, this carries 8 marks. Then differentiate between common gate, common drain and common source, it carries 8 marks. All these will carry 8 marks on the, all these are the questions based upon unit number 1. All we have covered under unit number 1. We will switch to unit number 2 in the next lecture. Now you can leave. Okay, this finishes your first unit.